I want to start with a feature from my own website. Surya Volume 2 was built. Beat the code existed. The comic reader existed. The page assets existed. But if you open the production website, the route returned 4 on 4. That is one of the most important lessons I have learned while building with AI. Finished code is not the same thing as a finished product, and a working demo is definitely not the same thing as production evidence. In this video, I will show you 4 real problems I found while building the Bharatvash website, how I fixed them, and the 8 checks I now use before I trust an AI-assisted application in production. By the end of this video, you will have a production readiness gate you can apply to an AI-built app. It covers context, tests, integrations, observability, cost and capacity, security and privacy, deployment and recovery, and human acceptance. When we reach the checklist, I will hold the important frames long enough for you to pause and take a screenshot. This is not an argument against AI coding. I use AI to build. I use coding agents. I use them across real systems. The argument is much simpler. AI can help build the app. Production trust still has to be earned with evidence. Let us begin with the positive evidence, because it matters. GitHub ran a randomized study with experienced developers completing a bounded API task. The developers with Copilot access were more likely to pass all 10 tests, and the study found small improvements in readability, reliability, maintainability, and conciseness. So the claim is not that AI always produces bad code. On a clear task, with a bounded problem and supplied tests, AI can help.
So if the code passes the tests, what is still missing?
The rest of the system. A real application is not only the function you ask the AI to write, it is authentication, state, database behavior, third-party services, browser behavior, deployment history, cost under traffic. And what happens at 2 in the morning when a user finds a path you never tested? This gap is visible in current research. In Stack Overflow's 2025 developer survey, more respondents distrusted the accuracy of AI tools than trusted it. 66% said one of their biggest frustrations was solutions that are almost right but not quite. And 45.2% said debugging AI-generated code was more time-consuming. Almost right is a dangerous category in software. Wrong code often fails loudly. Almost right code passes the demo, survives a quick review, and leaves the real problem for production. Dora's 2025 research gives us an even better way to frame this. It describes AI as an amplifier. Strong systems get more leverage. Weak systems expose their weaknesses faster. Dora found positive relationships with throughput and product performance, but the relationship with software delivery stability remained negative. That is the real issue. AI makes the first working version easier to reach. It does not automatically create the safety system around that version. I want to make this concrete with my own website, not because Bharatvash is uniquely fragile, and not because every bug was caused by AI. I am using it because I own the build, I can inspect the evidence, and I can show the difference between what looked correct and what production actually required. During a production review, I opened a forum thread on the live Bharatvash website. The page rendered. If I had only clicked around and looked at the screen, I could have called that a pass. But the browser console showed a React hydration error. The hidden problem was time. Some forum components were calculating labels with the current clock and locale-sensitive formatting while the page was rendering. The server could produce one value, the browser could produce another. Both values looked reasonable, but they did not match. The fix was not another vague prompt like, "Make the forum stable." The fix was to define stable behavior. The server now renders a deterministic UTC timestamp. Relative labels such as 5 minutes ago are calculated only after the browser has mounted. And a focused regression test checks both paths. The current live thread renders a stable timestamp, and the browser capture for this video produced no warning or error logs. Visual success is not runtime correctness. For browser applications, your gate needs more than a screenshot. It needs deterministic rendering, console inspection, and focus tests for behavior that can drift between environments. The second problem was in the forum rate limiter. The endpoint worked. It returned a successful response. It even returned the right rate limit headers. But inside the helper flow, the limiter was called once to check the request and a second time while building the headers. One request could consume 2 tokens.
But if the user received a 200, why call it a failure?
Because the response was successful while the state change was wrong. If your test only asks, "Did I get a 200?" this passes. If your test asks, "Did the system change state exactly once?" it fails. The fix was to return the original rate limit result and reuse that exact result when adding headers. Then I added a regression test for the invariant. One accepted request consumes 1 token. For this research pass, I verified the live behavior with 2 low-volume requests. The remaining quota moved from 59 to 58. This applies far beyond rate limits. For payments, permissions, inventory, queues, retries, and background jobs, test what changed, how many times it changed, and whether a retry would corrupt or duplicate the result. Then there was Surya Volume 2. The feature existed on a branch. The comic data and reader were there. But the production deployment branch did not contain that commit, so the live route returned 404. This is easy to miss when your attention stays inside the code editor. The agent can tell you the implementation is complete, the tests can pass on the branch, the build can even succeed locally. None of that proves what your users are running. The fix required a different chain of evidence. Check the live URL. Compare the feature branch with the actual deployment branch, promote the intended commit, build from clean source, verify the deployed revision and traffic. Then open the public page and the public assets again. Today, the live comics page lists Volume 2 and the public reader serves all 34 pages. Finished code is not deployed code, and deployed code is still not verified production behavior. After a deployment, I run low-volume smoke checks against the real public routes. That tells me the home page is reachable. The APIs respond, the comic assets load, the health endpoint is alive. Those are useful checks, but they do not prove how the system behaves with real concurrent users. They do not prove the database pool under pressure. They do not prove that hidden tabs are not wasting CPU. And they do not prove what the cloud build does when traffic and retries rise together. So did you load test Bharatvash for this video? No. And that distinction matters. For Bharatvash, I tightened some surrounding controls. Database pool parameters are wired into the actual connection URL. Continuous visual effects stop when the tab is hidden and respect reduced motion preferences. But I will not call the application load tested just because several routes returned 200. A capacity claim needs a separately designed test, expected workload, success thresholds, monitoring, and an explicit cost boundary. The lesson is not only to test more, it is to name exactly what your evidence proves. These 4 cases are personal. The wider pattern is not. Security research shows the same gap between functional output and production trust. Veracode's Spring 2026 benchmark reports that syntax correctness across the models it evaluated is now above 95%, while only 55% of generation tasks produced secure code. That does not mean 45% of deployed AI code is vulnerable. The study does not measure that. It means code can compile, run, and still fail a security requirement. A 2025 Usenix security paper found another risk: package hallucinations. In its evaluated setup, code-generating models sometimes recommended packages that did not exist. The rate was lower for the commercial model cohort than for the open-source cohort, but it was present in both. So if an AI suggests a dependency, do not install it because the name sounds plausible. Verify that the package exists. Verify the publisher, check the project health, scan the dependency tree, make sure it is the package you intended to add. Repository-level security benchmarks also show that functional correctness and secure correctness can separate dramatically. I treat those results as supporting evidence, not a universal production statistic, because the current studies are benchmark-specific and some are still preprints. The responsible conclusion is not, never trust AI. It is, do not use the wrong kind of proof. Here is the process. You ask AI for the feature. You fix visible errors until the happy path works. You click through the demo. You see the polished UI and treat that as acceptance. Then you deploy without proving state transitions, permissions, runtime logs, dependencies, cost behavior, recovery, or ownership. The mistake is not using AI. The mistake is allowing generation and validation to collapse into the same step. The system that produced the code should not be the only system deciding that the code is ready. Here is the gate I now use. Write down who uses the app, what job they are doing, what data is involved, which dependencies matter, and what correct behavior means. If the model does not have the real context, it will optimize for the prompt, not for the workflow. Test the happy path, but also test edge cases, permissions, state transitions, retries, regressions, and browser or environment differences. Every bug you fix should leave behind a focus test when practical. Verify authentication, database behavior, files, APIs, package identity, timeouts, and environment configuration. Do not let mocks become your only evidence. Make user-visible failures inspectable. Use structured logs, correlation IDs, or traces where appropriate, health signals, and alerts tied to behavior that matters. If the app fails and you cannot explain why, it was not ready. Those are the first 4. Pause here and take a screenshot if you want this half of the gate beside you during your next review. Now let us finish it. Count model calls, retrieves, storage, background jobs, database connections, and concurrency assumptions. Separate smoke testing from load testing. Define the workload and the cost boundary before you run the test. Check secrets, access boundaries, input handling, sensitive logs, dependency provenance, and abuse paths. NIST's Secure Software Development Framework and OWASP ASVs are useful starting points because they turn Be Secure into lifecycle practices and testable requirements. Know the exact build, revision, migration, environment, and traffic state. Test the new revision before full traffic when your platform allows it. Keep a rollback path. Verify the live URL after deployment. Cloud Run, for example, supports tagged revisions with no traffic, gradual traffic migration, and rollback. A named person must be willing to own the release. GitHub describes the pull request as an audit log and governance layer. Google's SRE production readiness review asks whether the service is ready across architecture, dependencies, monitoring, emergency response, capacity, change management, and performance. The final approval should come after the evidence is visible, not after the demo feels impressive. Pause here and take a screenshot for the second half. Cost and capacity, security and privacy, deployment and recovery, and human acceptance.
Do I need every gate for a tiny internal tool?
You need every question. The depth of evidence should match the risk. A personal prototype may need a lightweight answer. A payment flow, public community, regulated workflow, or customer-facing service needs much stronger proof. The gate scales. Ownership does not disappear. An AI-built app is not production-ready because the prompt was good. It is not production-ready because the UI looks polished. It is not production-ready because the code compiles. And it is not production-ready because it worked once on your machine. Production trust comes from evidence, context, tests, integrations, observability, cost and capacity, security and privacy, deployment and recovery, human acceptance. The question is not whether AI wrote the code. The question is, what evidence makes you willing to own it in production? Take one application you are building right now and run it through these 8 gates. The missing gate is probably more important than the next feature you were planning to generate. In the next build video, I will use these same criteria while building a simple AI agent from scratch, so we can see what production-minded AI development looks like from the beginning instead of adding it at the end.